The interior structure of the Earth is layered in shells, like an onion. The layers can be defined by their chemical properties. Earth has an outer silicate solid crust, a mantle, a liquid outer core, and a solid inner core. Seismic measurements show that the core is divided into two parts, a solid inner core and a liquid outer core. The core contains 1/3 of Earth's mass and has a radius of approximately 2,100 miles. The core is larger than the planet Mars, and the core is under enormous pressure. The inner core was discovered in 1936 and is composed primarily of iron and nickel. Because it can deflect seismic waves, it behaves as a solid and has a radius of about 600 miles. In early stages of Earth's formation, about 4.5 billion years ago, melting would have caused denser substances to sink toward the center, while less dense materials would have migrated to the crust. Recent research suggests that the innermost area of the core is enriched in gold or platinum. Recent evidence suggests that the inner core rotates slightly faster than the rest of the planet, approximately 0.3 to 0.5 degrees per year faster. The mantle extends 2,900 kilometers, making it the thickest layer of the Earth. It makes up for 2/3 of the Earth's mass. Earthquake waves pass through the mantle, indicating it is composed of solid rock matter. Mantle material is less dense than that of the core. The mantle consists of silicate rocks, high in silicon and oxygen. The upper mantle is divided into the lithospheric mantle and the asthenosphere. The upper and lower mantle are separated by the transition zone. The lowest part of the mantle next to the core mantle boundary is known as the D layer. Earth's solid exterior is the crust. It is composed of a great variety of rock types that respond in diverse ways and at varying rates to surface processes. The crust represents 1% of Earth's planetary mass. As the outermost layer of the solid Earth, the crust comprises the ocean floor and the continents and is of primary importance in understanding surface processes and landforms. The density of rock matter in crust is lower than that in the core and mantle. The oceanic crust is composed of basalt, a heavy, dark-colored, iron-rich rock that is high in silicon and magnesium. Basaltic rocks are the most common rocks on Earth. Continental crust comprises the major land masses on Earth that are exposed to the atmosphere. The average density of continental crust is less than that of oceanic crust. Continental crust, however, is considerably thicker than oceanic crust. At places where continental crust extends to high elevations in mountain ranges, it also descends to great depths below the surface. Continental crust contains more light-colored rock than oceanic crust does and can be regarded as.
The rock cycle is a conceptual model for understanding the process that generates, alters, transports, and deposits mineral materials to produce different kinds of rocks. The term cycle emphasizes the existing rock supply, the materials to make new and sometimes very different rocks. Rock matter does not have to go through every step of the cycle. Example, after igneous rocks are created by the cooling and crystallization of magma or lava, they can weather into fragments that lithify into sedimentary rocks. Igneous rocks, however, could also be remelted and recrystallized to make new igneous rocks or change into metamorphic rocks by heating and pressure. Sedimentary rocks consist of particles and deposits derived from any of the three basic rock types. Metamorphic rocks can be created by the means of heat and pressure, changing any pre-existing rock, igneous, sedimentary, or metamorphic, into a new rock. With sufficient heat, any rock can melt into magma that will eventually cool and solidify into an igneous rock. The rock cycle includes all of the possible pathways for the recycling of rock matter. Metamorphic means change from. Metamorphic rocks are typically harder and more compact, have a reoriented crystalline structure, and are more resistant to weathering. Two categories based on presence, foliated, or absence, non-foliated, of platy surfaces or wavy alignments of light and dark minerals that form during metamorphism. Metamorphism occurs when crystal rocks are subjected to great pressure by a tectonic process or deep burial, or where rising magma generates heat that modifies the nearby rock. Metamorphism causes minerals to recrystallize with enough heat and pressure to reprecipitate perpendicular to the applied stress, forming platy surfaces or wavy bands. Slate, shales that change to a hard metamorphic rock which exhibits a tendency to break apart along smooth flat surfaces that actually represent extremely thin foliation planes. When foliation develops into broad mineral bands, the rock is extremely hard and is known as gneiss. Coarse-grained rocks such as granite generally metamorphosize into gneiss, whereas fine granite rocks tend to become schist. Limestone is metamorphosized into much denser marble.
Igneous rocks are when molten rock material cool down and solidify. Magma is molten rock below the Earth's surface. Molten at the surface is called lava. Lava is the only molten rock that we can see. Lava erupts from volcanoes at the Earth's crust at temperatures near 2000 degrees Fahrenheit.
Extrusive igneous rocks are molten material that solidifies at the Earth's surface. This is also called volcanic rock. Extrusive rock is made from lava, therefore it has a super explosive eruption of molten rock. This can cause pyroclastic, which is fragments of volcanic rock.
Intrusive igneous rock that solidified within Earth from magma, also called plutonic rock. The chemical composition of igneous rock varies from phlogistic, which is rich in light-colored, lighter weight minerals, especially silicon and aluminum. Sedimentary rocks are formed by compactation and cementation of rock fragments or organic remains or chemical precipitates. Clasts are broken fragments of solids. Clasts consist of clay, silt, and sand to gravel. Clasts are previously existing rocks, shells, bones that were deposited on riverbeds, beaches, sand dunes, lake bottoms, and the floor of the ocean. Class sediment rocks are pre-existing rocks, shells, or bones. Examples are sandstone, siltstone, and shale. Organic sedimentary rocks are rocks created from deposits of organic material such as carbon from plants. Coal is an example of this. Coal is created by partially decayed vegetation in swampy environments. Chemical precipitate sedimentary rocks are rocks created from dissolved minerals that have precipitated out of water. Limestone is an example of this. Stratification is distinctive layers within sedimentary rocks called stratus. Bedding plane is boundaries between two sedimentary layers that represent separate events. Cross-bedding are thin layers with sedimentary rocks that were deposited at an angle to the dominant rock lathering.